Hi everyone, so let's do today's Delay Code challenge question. I'll just do it for 15 minutes and then I'll look for the solution. So 15 minutes has started. Let's try to do minimized maximum of products. Is it streaming or not? Yeah, it is streaming because yesterday it stopped in between. So minimized maximum products, maximum, it is already 9:45 p.m. Minimize maximum of products distributed to any store. Okay, so you are given integer n, indicating n, especially indicating that there are n specialty retail stores, indicating that there are n, okay, retail stores. There are m product types of varying amounts, okay, which are given as a zero indexed integer array quantities where one is represent the number of products in the on the ith product types. Okay, so there are m product types, and so suppose this is the product type, and then there are 11 products of, suppose 11 toothbrushes, 6 pillows, something like that, you need to distribute all products to the retail stores following these rules. A store can only be given at most one store can be given only at most one product type, but can be given any amount of it. Okay, so if there are like 6 stores, right? 1 2 3 4 5 6, so I can give this first store only one product type, but I can give any amount of it. Suppose I can give this store like 5 product of this type, and but I cannot give this 5 product of in this type and 5 product of this type. I can only give one store one product type. So after I need to minimize maximum of, so after distribution, each store will have been given some number of products, possibly 0. Let x represent the maximum number of products given to any store. Okay, you want x to be as small as possible. Okay, you want to minimize the maximum number of products that are given to any store. Okay, return the minimum possible x. Okay, so let's look at this example. So there are 6 stores, right? And I want to minimize the maximum number of products that are given to any store. So here since I only have 17 products and I have 6 1, so 17 divided by 6, and I need to distribute all products. So 6 4 is 6 3 is 18, 6 3 is 18, right? 6 3 is 18, 6 2 is 12. So it means that if I distribute 2 2 2 2 2 and 2 2 5 is 10, so 7 will be remaining, and then I can distribute 7 to this one, right? Something like this. Or if I distribute this 3, then it will be 6. I distribute this 3, then it will be 5. I distribute 3 to this one, then it will be 4. Something like this, so I have to distribute all the products. But also there is another constraint. That constraint is I can distribute only one kind of product to each store. I cannot distribute. So suppose this 2 2 6. Okay, so main thing, so there is so another thing that I want to minimize, right? So I can minimize by sharing. So the one way to minimize number of products given to any store is to distribute the products equally to all stores, right? So suppose if there were 18 products, then if I distributed 3 3 3 to each, then that is nice, right? but if I do not distribute it equally, then if I distribute just one to them, then that sphere should be given to another one, so another one will receive more. So that is why the best way is to distribute the products equally to all stores, so that products won't be skewed to just to one or more stores. Okay. Yeah, we could do that, but we cannot just divide and rule, right? We cannot just to divide, like divide it by some number and then do that, because there is a restriction that only one we can divide, because there is a restriction that we can give to store only one kind of product. We cannot just give them any kind of product. So if we could give them any kind of product, then we could just sum the number and then divide it. But since we can only give one kind of product to one store, so it is not so. So that way, what we should do is, if only one kind of product I can give, then what can I do? Yeah, first of all, I'll just look at the example. Okay, maybe if I just try to do the example, then I will get the solution. So 1 2 3 4 5 6, and quantities are 11 and 6, so it means that since there are 11 of one type, so we do 1 suppose if I give 1 of each quantity of one type to all the store, then I will not be able to distribute this to any store, yeah, I will not be able to distribute that to any store or other store. Suppose if I give this 2, so what can I do then? 11 6, I only have 6 minutes left. 11 and 6, I don't know what I can do. 11 quantities of one kind and 6 quantity of one kind. I can only distribute one quantity, and I want to reduce the number that I give to any store, and to reduce the number of quantities that I give to any store. So let's start with 6 first. So since there are 6 stores, no, let's start with 11 only first, because I want to make sure that the bigger number gets distributed first. So since this is 6, right, so it means that I have 1 6 and 1 11. So 6 I should distribute to some stores, and 11 I should distribute to some stores. If I distribute 6 and I distribute 11, how could I distribute them equally? 11, I can distribute it as maybe I have 6 stores. I distribute as 3 3, and this one 3 4 is 12, 2 3 3 3 2, right? I can just distribute 2 3 3, and I can just distribute 3 3 3 2, totally 6. 3 3 is 9 10 11, right? So is there any other way? Output is 3. See, the 11 types are distributed to first 4 stores in these amounts. 6 products of types are distributed to in that amount. Okay, let's look at this one. N is equal to 7 and quantities is 15, 10 and 10. So quantity is 15 10 10, and I will distribute it to 7 stores 7 times. I have 15 10 and 10 means 1 2 3. I have 1 2 3 4 5 6 and 7 stores, right? So and I have to distribute everything to 7 stores. 15 10 10 20 20 35 35 divided by 7, 7 5 is 35. Oh, nice. Yeah, this is easy. 5 by 5. Here also 11 17 divided by 6 is 6 to 12. Yeah, I still can think of a solution though. Like, is this a solution? Should I sum everything and then first of all divide to 7 and think about? Yeah, I think so, right? The summing and dividing by total number of stores should work, because then we will know that this is the number that if we equally distribute, it will be distributed. Here also there are 17 quantities, right? And 17 divided by 6 is 6 3 is 18, 6 2 is 12, 5 50, 6 4 is 6 5 is 6 6 is 36, 6 7 is 42, 6 8 is 48, 12. Yeah, 6 8 is 48 and something like that, you know. And 20, 6 2 is 12, 6 3 is 18, something like this. So we know that it is 2.83, means if we divide 2.83, 2.83, 2.83, or suppose if it was 3, suppose this was 6, suppose this was 7, then the answer would be 3, right? 18 divided by 6 would be 3. So it means that if I just divide 3 3 3 3 3 3, then this will give me the least amount. But I cannot do this 3 3 3 3 3, you know, because I just have 11. So I can just divide 3 3 3 3 6 7 8 9 10 11, and for this one, for 7 I could do, no, yeah, I cannot do 3 in this case, because 7 would be 3 and 4. 4 5 6 7. Yeah, there is no any other way to divide 7, right, other than 3 and 4. Or I could have done 3 3 6 and 1, but that is not a good approach, because if I had done 3 3 1 for 7, then this 3 would have, we could have this would have been divided by 11. So 11 divided by 3 is 3. 3 2 is 6. 3 3 is 9. 3 4 is 12. 3 point something. So 1 would be 3 and 1 would be 4. Yeah. Let's look at the editorial now. Binary search on the answer. Greedy approach using a heap. Oh, you mean a natural approach is to, given the parameters and then this can we determine if it's possible to distribute the product such that no store receives more than X products? Oh, this is the idea. We want to find the smallest X for which any valid such a valid distribution exists, ensuring no store gets more than X products. Okay. Okay, so they are using binary search to find the smallest valid X. And this is so actually this is a two-way question. So one question is this is one question. So if we are given X, then we need to find if it's possible to distribute the products such that no store receives more than X products. Suppose if it was 1, okay, then is it possible to distribute the products such that no store receives more than X products? So it is possible to distribute, right? 1 1 1 1. No store receives more than X products. So suppose X is equal to 4. Then is it possible to distribute the products such that no store receives more than X products, more than 4 products? Yeah, it should be possible. Not more than 4. Yeah, so that is one question. Another one is to um, just to do binary search like this. So this is the can distribute function, right? So this is the can distribute function. So going to do the first not fully distribute. We are looping through each stage and checking if the remaining quantity of the jth product type can be fully distributed to the ith store, and if yes, move the pointer to the next product type. Check if all products have been distributed. Distribute the maximum possible quantity to the ith store. Okay, yeah, so this is how we can find that, and then use binary search to find the minimum max possible. So what is greedy approach? Key idea is to assign stores to product types in an optimal way rather than assigning products to stores. Yeah, I was trying to do greedy there. Initially each store, its product type is assigned one store is guaranteed. After this we focus on wow. It's an interesting solution. Okay, so yesterday's was also binary search. This is also binary search. Okay, actually, yeah. My 20 minutes are already over, and this is a good problem and a tricky solution, I must say. I need to think about how to come up with such solutions in the first place. Yeah, I'll think about that.